गुड इवनिंग स्टूडेंट्स, वेलकम टू द चैनल फिजिक्स फन। तो हम लोग लास्ट टॉपिक में जो था, हम लोग कहाँ पर थे? दैट वाज न्यूटन्स लॉज ऑफ मोशन। टुडे we'll start the part 2 of Newton's laws of motion. What is the first topic? First topic is graphical method for measurement of impulse. Number one, for constant force. What is constant force? The forces whose value is unchangeable. That is, if equals to 1 Newton, maybe for an example 2 Newton, 3 Newton, etc. Now for the constant force, draw a graph. This is OX and OY. O is the origin. Let us take the force along OY axis, and OS axis is time. Now as it is a constant force, let us take a parallel graph to the time axis. Now draw perpendicular over the time axis. If it is the force F and it is the time T, then the area covered by the graph is the impulse of force, that is F into T. F into T. Now second case, for variable force. Let us draw a graph first. OX, this is OY. Along the y-axis we take the force, and along the x-axis it is time. Now the graph we consider, it may be like this. Now let us take a streak. It is starting from 0 to that is T. Now let us take a strip that is dt, and the here AB, and the force is F. Now for the small strip, the impulse of force dg is equals to F into dt. Now the total impulse of force J is equals to integration starting from 0 to T F dt, which is the area covered under the graph. From the Newton's third law of motion, we all know that to every action there is equal and opposite reaction. To every action there is equal and opposite reaction. Let's explain it. A spring body system, the spring which is connected to the wall and the other end connected to a block. If a force applied on the block, then the length contraction of the spring will be happened. And when the force is disappeared, the block will move towards forward direction because of the reactional force. Reactional force. F is the action and F dashed is the reactional force. So F is equals to minus F dashed. F is equals to minus of F dash. So to every action there is equal and opposite reaction. Let's move to the third topic, apparent weight of a person on the elevator or lift. Now take the first case, number 1. This is the lift. A person standing on the lift, standing on the floor of the lift. Now the lift is moving upward direction with the uniform acceleration A. Uniform acceleration A. Now let us take the force acting on the person. Its weight in the downward direction are perpendicular to the floor of the lift, and the reactional force opposite to the weight. Now the lift moving in the upward direction, in the upward direction. So the resultant force is equals to R minus mg. Now from the Newton's laws of motion, we know that force is equals to m into a, that is the acceleration, mass into acceleration, is equals to r minus mg. That is r minus mg is equals to m into a. Now r equals to mg plus m into a, that is equals to m common g plus a, which is the reactional force acting on the person when the lift is going in the upward direction. Now let's move to the second case. Lift is moving in the downward direction. Lift is moving in the downward direction, in the downward direction with the uniform acceleration a. Now as the lift moving in the downward direction, so mg is greater than r. So the resultant force is equals to mg minus r. That is F equals to. We know that F equals to m into a. That is equals to mg minus r. So mg minus r equals to m into a. Now minus r equals to ma minus mg. Now r equals to m common g minus a. That is the reactional force when the lift is coming down. Lift is coming down with the uniform acceleration a. Now let's move to the third case. Third case. Lift moving downward direction with uniform speed. As the speed is uniform, so their acceleration should be 0. Now we know that r equals to m into g minus a. As there is acceleration 0, so putting 0, that is r equals to mg. Reactional force is equal to the weight of the person. Weight of the person. Now moving towards the fourth case. Towards the fourth case. Moving downward. Moving downward with acceleration a equals to g. Now here a equals to g. We know that r is equals to m into g minus a. Now putting a equals to g, we have r equals to m into g minus g, that is reactional force is coming 0. What it means? It means that the person standing on the floor of the lift feels weightless. So he feels his apparent weight is 0. Apparent weight is 0. Now let's move to the fifth case. To the fifth case. To the fifth case. Lift is moving in the downward direction, but acceleration of it is greater than 0. So the person standing on the floor of the lift will certainly leave the floor and his head touching the floor, touching the roof of the lift, just like that. Now the weight acting in the downward direction, that is mg, and the reactional force also acting in the downward direction. So for this, the resultant force is equals to r plus m into g. Now from the equation of motion we have F equals to r plus mg, and F equals to ma is equals to R plus mg. So R is equals to ma minus mg. So R is equals to m common a minus g. A minus g. Now let's move to the connected motion. Connected motion. First we have to take the case of the fixed pulley. Now let's draw a fixed pulley. Pulley is fixed. Fixed pulley. And the two objects with the same string has been connected with the pulley. Let's the mass of the one block is m1 and the second is m2. If m2 is greater than m1, then the motion should be m1 in the upward direction and m2 is in the downward direction. Now let's show the forces acting on the objects. This is the weight of the first object and the tension certainly acting in the upward direction. And for this, it is the m2g and it is also the tension T. As the string has been used in that case is the same and inextensible. Now for the first block, for the free body diagram FBD, what is that? Free body diagram. For free body diagram, for the first block, that is m1g and that is the tension T and it is moving in the upward direction. If the acceleration of the total system is a, then from the Newton's laws of motion, T minus m1g is equals to m1a for the first case. Now for the second case, free body diagram, that is m2g and the tension acting in the upward direction and the body is coming in the downward direction. As the body is coming downward direction, we have m2g is greater than T, that is m2g minus T is the resultant force, that is equals to m2a. That is the second equation. Now we have to find the tension and the acceleration. Tension and the uniform acceleration of the blocks. So here, if we solve it, T will be cancelled out. T will be cancelled out. So we have m2g minus of m1g is equals to m1 plus m2 into a. Now here m1 plus m2 a is equals to m2 minus m1 into g. So we have a is equals to m2 minus m1 by m1 plus m2 into g, which is the uniform acceleration of the blocks. Now to find the tension of the strings. Now to find the tension of the string, let us take the second equation and putting the acceleration there. m2g minus T is equals to m2 into m2 minus m1 by m1 plus m2 into g. Now minus t is equals to minus of m2g minus m2 plus m2 into m2 minus m1 by m1 plus m2 into g. So T is equals to, that is the tension. What is this? This is the tension. Tension is equals to m2g minus m2 into m2 minus m1 by m1 plus m2 into g. That is equals to m2 commons out from that equation, m2, and here 1 minus m2 minus m1 by m1 plus m2, and g has been also separated from there. So we have that is equals to m2. Now taking the LCM, m1 plus m2 minus plus minus m2 minus minus plus m1 upon m1 plus m2 into g. That is equals to m2 into m2 will be cancelled. There should be m2 m1 by m1 plus m2 into g. That is equals to 2 m1 m2 by m1 plus m2 into g. T is equals to, that is the expression of the tension of the pulley. Now let us take the 3 blocks for a fixed pulley case. Mass of the first block is m1. Here is the mass on the second block is m2, and that of the third is m3. Now here we have to find the T1 and here the T2. Now first we have to find the acceleration of the system. Acceleration of the system. Acceleration of the system should be the same for the all blocks. Now, how to find the acceleration? Let us take the body is moving in that direction, So here m2 plus m3, m2 plus m3 is greater than m1. m2 plus m3 is greater than m1. Now the acceleration, now to find the acceleration, E is equals to, we know that is the force, total force by the total mass m. Now here the resultant force F is equals to the weight of the 2 blocks m2 plus m3 into g minus the weight of the first block, that is m1g. We have m2 plus m3 minus m1 into g. Now the total mass is equals to m1 plus m2 plus m3. So the acceleration becomes A is equals to m2 plus m3 minus m1 by m1 plus m2 plus m3 into g, which is the acceleration of the system. Now moves to the first body. We have the tension acting in the upward direction and m1g acting in the downward direction. So here the equation of motion T1 minus m1g minus m1 G, that is equals to m1 into A. So we have T1 is equals to m1 comes out G plus A. Now here T1 is equals to m1 into G plus m2 plus m3 minus m1 by m1 plus m2 plus m3 into G. So we have m1G into 1 plus m2 plus m3 minus m1 by m1 plus m2 plus m3. Taking the LCM, m1G into m1 plus m2 plus m3 plus m2 plus m3 minus m1 by m1 plus m2 plus m3. So we have the m1 will cancel out. We have 2m1 into m2 plus m3 by m1 plus m2 plus m3 into G. That is the tension on the first block. On the first block. Now moving towards the tension acting on the M3 mass. Here we have the equation M3 G minus T2 is equals to M3 A. Now T2 is equals to M3 into G minus A. Now M3 comes out. We have G minus M2 plus M3 minus M1 by M1 plus M2 plus M3 into G. That is M3G into taking the LCM M1 plus M2 plus M3 minus plus minus M2 minus plus minus M3 minus minus plus M1 by M1 plus M2 plus M3. So M2 cancel out, M3 cancel out. So we have 2M1 M3 by M1 plus M2 plus M3 into G. That is the tension acting on the string of the third block. So it is all for the day. Please share, subscribe and like and support us.